the inspector is correct. According to the National Electrical Code, or NEC, a main breaker is required for any electrical panel regardless of the number of switches. The main breaker serves as the overcurrent protection device for the entire panel, and it is used to disconnect power to the entire panel in the event of a fault. In the described case, there is a 100 amp meter socket and a 100 amp panel with main lugs. The main lugs are where the main breaker is installed. Since a 100 amp meter socket has already been installed, a 100 amp main breaker will need to be installed in the panel. Once the main breaker has been installed, it will then be in compliance with the NEC. To elaborate further on the requirements for main breakers in electrical panels, it is important to understand the fundamental principles of overcurrent protection and electrical safety that underpin the NEC. Overcurrent protection is a critical aspect of electrical system design, intended to prevent damage to equipment and wiring, as well as to minimize the risk of electrical fires and other hazards. An overcurrent can occur due to a variety of factors, including short circuits, ground faults, and excessive loads on circuits. Short circuits involve an unintended low-resistance connection between two conductors, typically a hot wire and a neutral or ground wire. This results in a very high current flow, which can quickly overheat conductors and cause insulation to melt or ignite. Ground faults occur when a hot wire comes into contact with a grounded surface, such as a metal enclosure or a grounding conductor. This also results in a high current flow, although typically lower than a short circuit. Excessive loads on circuits occur when the current drawn by connected devices exceeds the ampacity of the circuit conductors. This can happen if too many appliances or equipment are plugged into a single circuit, or if a device malfunctions and draws excessive current. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overcurrent condition. These devices are rated in amps and are selected to match the ampacity of the circuit conductors they protect. When an overcurrent occurs, the protection device will trip or blow, opening the circuit and stopping the flow of current. This prevents the conductors from overheating and potentially causing a fire. The main breaker in an electrical panel serves as the primary overcurrent protection device for the entire panel. It is sized to match the ampacity of the main service conductors feeding the panel and is intended to protect the panel and all of its branch circuits from overcurrent conditions. The main breaker also provides a convenient means of disconnecting power to the entire panel for maintenance or emergency purposes. In general, the NEC requires that all electrical panels be equipped with a main breaker, regardless of the number of branch circuits they serve. This requirement is intended to ensure that all panels have adequate overcurrent protection and a readily accessible means of disconnecting power. There are a few exceptions to this rule, such as for certain types of control panels and for panels that are fed from a separately derived system with its own overcurrent protection. However, for most typical electrical panels, a main breaker is required. In the specific scenario of a temporary pole service with a 100 amp meter socket and a 100 amp panel, the NEC requirement for a main breaker is particularly important. Temporary power services are often used in construction sites and other temporary locations where electrical conditions may be less than ideal. The presence of a main breaker in the panel provides an additional layer of protection against overcurrent conditions that may arise due to faulty equipment, damaged wiring, or other hazards. In addition to the NEC requirement for a main breaker, there are also other safety considerations to keep in mind when installing and using temporary power services. Firstly, all wiring and equipment should be installed in accordance with the NEC and other applicable codes and standards. This includes using properly sized conductors, ensuring that all connections are tight and secure, and providing adequate grounding. Secondly, all equipment should be inspected regularly for damage or wear. This includes checking for frayed or damaged cords, loose connections, and signs of overheating. Thirdly, ground fault circuit interrupters, or GFCIs, should be used to protect all receptacles that are used in wet or damp locations. GFCIs are designed to detect ground faults and to quickly interrupt the flow of current, preventing electrical shock. Finally, workers should be trained on the proper use of electrical equipment and on the hazards of electricity. This includes teaching them how to identify and avoid potential hazards, how to use personal protective equipment, and how to respond to electrical emergencies. When selecting a main breaker for an electrical panel, it is important to choose one that is properly sized for the panel and for the service conductors feeding the panel. The ampacity of the main breaker should not exceed the ampacity of the service conductors, and it should be sufficient to handle the expected load in the panel. It is also important to choose a main breaker that is compatible with the panel. Main breakers are available in a variety of sizes and configurations, and it is important to select one that will fit properly in the panel and that will make proper electrical connections. When installing a main breaker, it is important to follow the manufacturer's instructions carefully. This includes ensuring that the breaker is properly seated in the panel, that all connections are tight and secure, and that the breaker is properly labeled. It is also important to test the breaker after installation to ensure that it is functioning properly. This can be done by using a circuit tester or by simulating an overcurrent condition. To further clarify the role and necessity of the main breaker, consider the following points. The main breaker acts as the first line of defense against overcurrents entering the panel. Without it, the entire panel and all connected circuits would be vulnerable to damage from faults occurring upstream in the electrical system. While branch circuit breakers protect individual circuits, the main breaker protects the entire panel bus and internal components. The NEC mandates the main breaker to ensure a standardized level of safety and protection across all electrical installations. This helps to prevent inconsistencies and potential hazards that could arise if panels were allowed to be installed without main breakers. The main breaker provides a single point of disconnect for the entire panel, which is essential for safety during maintenance, repairs, or emergencies. This allows qualified personnel to quickly energize the entire panel, reducing the risk of electrical shock or other hazards. The size of the main breaker is carefully determined based on the service entrance conductors and the overall load calculation for the electrical system. This ensures that the main breaker is capable of handling the expected load while still providing adequate overcurrent protection. In addition to the overcurrent protection provided by the main breaker, it also helps to protect against voltage surges and other electrical disturbances. Surge protection devices can be installed at the main panel to protect the entire electrical system from these types of events. The NEC requirements for main breakers are regularly updated to reflect advances in technology and changes in electrical safety standards. It is important to stay up to date on the latest NEC requirements to ensure that electrical installations are safe and compliant. When inspecting electrical installations, inspectors will typically check to ensure that the main breaker is properly sized, installed, and labeled. They will also check to ensure that the breaker is functioning properly and that there are no signs of damage or overheating. If an electrical panel is found to be without a main breaker, the inspector will typically require that one be installed before the installation can be approved. This is to ensure that the panel meets the minimum safety requirements of the NEC. In the case of the temporary pull service, the inspector's requirement for a main breaker is not only code compliant but also a responsible safety measure. Temporary power setups, by their nature, are often subject to more demanding conditions and potential hazards than permanent installations. Therefore, having the main breaker in place provides an essential safeguard against electrical problems that could arise during the construction process. To summarize, the NEC requires a main breaker in virtually all electrical panels, regardless of the number of branch circuits. This requirement is intended to provide overcurrent protection for the entire panel, to provide a means of disconnecting power for maintenance or emergency purposes, and to ensure a standardized level of safety across all electrical installations. While there may be a few limited exceptions to this rule, they are not applicable in the typical case of a temporary pulse service or other common electrical panel installations. Therefore, the inspector is correct in requiring a main breaker for the 100 amp panel. Ignoring this requirement could lead to safety hazards and code violations. It is also important to recognize that the NEC is a minimum standard and that in some cases it may be necessary to exceed the NEC requirements to ensure adequate safety and reliability. For example, in certain high-risk environments, it may be desirable to install additional overcurrent protection devices or to use more robust wiring methods. The main objective of electrical design and installation should always be to create a safe and reliable electrical system that protects people and property from the hazards of electricity. This includes not only complying with the NEC but also considering the specific needs and conditions of the installation and taking appropriate measures to mitigate any potential risks. Considering the fact that it is a temporary service for a construction site, other items to take into consideration are to ensure that all cords being utilized are rated for outdoor use, that the cords are not damaged, and that they are of the correct gauge for the amperage being drawn. Also, all the equipment plugged into the temporary service must be properly grounded. It is the responsibility of the installer to ensure that the proper installation methods have been used for all equipment used in the project. If there are any questions, ask a qualified electrician. This is more important on a construction site with multiple people utilizing the electrical service. One other item to consider is the use of ground fault protection on all branch circuits. Since the construction site will be exposed to the elements, it is always recommended to utilize ground fault protection for personnel. This will help protect the workers from any potential shock hazards. Also, be sure to inspect all equipment on a daily basis to look for any potential hazards. If any are found, they should be addressed immediately. Do not allow any damaged equipment to be used on the project. All electrical equipment should be properly maintained and inspected regularly to ensure that it is safe to use. By following these guidelines, you can help to ensure that the temporary electrical service is safe and reliable. This will help to protect the workers from electrical hazards and prevent any potential accidents. In conclusion, the inspector is correct in requiring a main breaker for the 100 amp panel. This is a code requirement and a safety measure that should not be ignored. By following the NEC and using good electrical practices, you can help to ensure that the temporary electrical service is safe and reliable. Also, always be sure to check with the local authority having jurisdiction for any local amendments to the NEC. They can clarify any questions about the electrical requirements in the area. Remember, safety is always the top priority. Take the time to do the job right and ensure that all electrical work is done in accordance with the NEC and other applicable codes and standards. This will help to protect people and property from the hazards of electricity.